Hello everyone. So in the previous lecture, we have discussed about the measures of dispersion and we talked about two parameters. One was range and another one was quartiles, right? So in this lecture, we'll discuss few more measures of dispersion. So the first one is the variance or the standard deviation. So variance is sigma square or s square and standard deviation is sigma or s. So for ungrouped data, what is the variance formula? It is for the case of a population, it is summation of sigma square equal to summation of xi minus mu whole square. So in this case, sigma square equal to summation of xi minus mu whole square divided by n. But this mu is the mean value, xi is the individual value, n is the all the number of data. And for the sample, if you have the sample, and for the case of the ungrouped data, the sample variance formula is the summation of xi minus x bar whole square divided by n minus 1. What is this n? Small n is the number of sample data, but make sure that for the case of a sample data, we do not divide it by n, but by n minus 1. And then we have for the group data, what is the value? The we have discussed for the mean value, right, in the previous lectures. Now we are discussing about the group data. What is the variance formula? We denoted the variance by sigma square, and it is the summation of f into x minus mu whole square divided by capital N. F is what? It is the, because in this case you will have a frequency table, so f is the frequency of each of the class. X is what? This small x is the midpoint of the that interval. Mu is the mean, and n is the number of points. And similarly, if the data is a sample data, in this case, it is the similar kind of formula, f into x minus x bar whole square divided by n minus 1. Clear? So we'll discuss through some example. So in some data, if you have seen that some data is given and you have been asked to find the what is the variance, what is the standard deviation. In this case, if it is nothing mentioned explicitly, you consider them as a population data, and you apply these formulas. Got it? To get the result. Sometimes variance is also referred as a second central moment. Now let us see one example. Now look at the same data as we have discussed in the previous example, previous lecture, that we have the data of 10 students, the marks of 3 tests. The first test, all the students got 10, 10, 10, 10 marks. In the second test, some of them got 8, some got 9, some got 10, some got 11, some got 12. In the third test, some got 5, some got 10, some got 15. Correct? Now in this case, how to find the, because they are the ungrouped data. Now what is the standard deviation formula? Summation of xi minus mu whole square divided by n, right? So but the mean is, in all the cases mean is 10. We have already discussed this thing. So data xi minus mu, in this case all that xi minus mu value is 0, 0, 0. So the standard deviation value is actually 0 in this case. But what about this case? In the second test, the xi minus mu value is, the mean value is 10. So in this case, xi minus mu whole square is equal to, it is 10 minus 8 whole square. In this case, 10 minus 9 whole square. Again, similarly, you do it all these things. So all these cases will be 0, 0, 0, right? Again, it is 10 minus 11 whole square, then 10 minus 11 whole square, and 10 minus 12 whole square. So if you choose do this data, so this is basically 2 square means 4 plus 1 plus 1 plus 1 plus 4. So if you do all this calculation, this is divided by 4, then you will get the variance, and to get the standard deviation, you have to do the root of it. Basically, this will give you the, this value is actually 4 plus 1. All these are 0, 0, 0. From here onwards, again 1 plus 1, and here 4. So 4 plus 1, 5, 6, 7 plus 4, 11 divided by number of data point was 10. So it is 1.1. This is the variance for the second test. And then standard deviation is that square root of this value, 1.1. Standard deviation is sigma is equal to this value. So you'll be getting this value is 1.09. Right. So here in this case, we have seen it's a little bit moderate variance is there. At the same time, if you check the test 3 values, if you calculate the variance the same way, so 5 minus 10, so 10 minus 5 whole square, right? So in this case, I am calculating the sigma square value, this value, it is 10 minus 5 whole square. What is that? 5. square. So 25. Here also 25. Here it is 0, 0, 0. All this case it is 0, 0, 0. Up from here onwards it is 25, and here also it is 25. Right? So all total value is 100 divided by 10. So it is 10. Sigma square is 10 in this, the third test. And then the standard deviation, if I just do the root of 10, you'll be getting this is the standard deviation, and you see that the value is little higher than this value. So in this, among these three data, test 1, test 2, and test 3, all of them have the mean is same, but their variance is more. So in this case the variance is little more, in this case it has a high variance, right? So this variance signifies how the data are varied with each other, right? Where the mean cannot able to identify them. Then we have this example, and you have to find the variance of this thing. So what you have to do? So for group data, you have to find the variance, right? So your first job is to find the mean. Now what is the mean formula? Mean formula is equal to mu is equal to, now if nothing is given, so we'll consider it is a population data. So mean formula is what? Mean formula was, we have done it in the previous classes. It is summation of fi into xi divided by sum of fi. That means number of points. Right? What is fi? Fi is the frequencies of each of the class. Xi is what? It is the midpoint. So we need to get the mean first. And after that, we have to get the variance. What is the variance formula? So in case of a group data, variance formula is summation of f into x minus mu whole square divided by capital N, because we are taking the population data. So to do this kind of variance and all these things, you have to make the table. Correct? So what are the things you have to get it in the table? You have to find a very big table, and slowly you have to find all the values from the table. Correct? So first you make the class value. The next job is frequency, small f, frequency of that class. Next is what? The midpoint x. Midpoint x in the midpoint in the interval, basically. Then we have to do that to get the formation of fi xi. So f into x, the midpoint into x value, calculate this value. Next is what? You have to get that this kind of value. So x minus mu whole square. So x minus mu whole square you calculate. And finally you have to calculate f time x minus mu whole square. Right? So for each of the class interval, you have to find this value to get the mean and variance. Now class interval is 0 to 10. In this case, what is the frequency? Right? Frequency was given already 5. Now what is the midpoint of this class? It is 10 minus 0 by 2, so it is 5. What is f into x? So it is 25. What is x minus mu whole square? So this part we will do it after calculating this x minus, like the mu value. So first we have to finish this, the mu calculation, right? So we have to finish the mu calculation first. And finally, this problem we have done for mu calculation, we have already done. So finally, we'll be getting mu value is equal to, after doing this formula, it is 27. We have done this problem earlier, right? So x minus mu value is what then? So your first job is to calculate the mu value that we have already calculated in some of our earlier example, which was 27. Right? Now I know this mu value, so we can able to get x minus mu whole square is what? So 27 minus 25 whole square. So it is what? 27 minus mu. X minus mu. X is what? 5 minus 27 is whole square. So it is 22 whole square. Right? And 22 whole square is actually equal to 480. And same way f into x minus mu whole square. So f 5 times 484. So this value is equal to actually 2420. Now in this way, can't you finish all these values? F value, what is the midpoint, and all is that value? So we can just put it in the formula, and we can finish the table by calculating all the values. For each of the point 10 minus 20, it is frequency is this, midpoint is this, fx value. This is I needed to get the mu value calculations. So first you finish up to this part, then you calculate the fx by summation f, that will give you the mu value, and once you have the mu value, you finish the table from there. correct? So summation f into, so now the sigma formula is this one, the variance formula. So that means this value we have to add them up. So if I add all of them, it is 6600 divided by summation n is the summation of f. That means the frequency, number of points you have to add. This is divided by 50, so this value will be 132. Again, as I mentioned in the earlier problem, these problems are actually very, very easy, but it will take time, so you have to do very carefully. If you do one mistake in some one small place, suppose mu calculation you have done a mistake, so the whole table will be wrong, right? Here, everything will be wrong. So calculate everything is very slowly and carefully, right? Suppose somewhere you just you made a mistake to find the midpoint. Again, it will affect here. These things will affect the, then it will affect the mu calculation. Then it will affect every places. So very carefully, each of the things you do it, do all of them and get the correct answer. I hope it is clear. I have kept two examples. So for this one also, you do the same way, the calculation. Find the mean value first, and then find the variance of this data. Another one, we have it. So please finish these two examples. Now next is we will discuss another parameter, the measures of variation only, that is the mean absolute deviation. What is that? Mean absolute deviation is a measure of variance that quantify the average distance between each data point and the mean of the data set. Right? So basically, mean absolute deviation it is 1 by n into summation I equal to 1 to mod of xi minus mu. Where in the case of standard deviation, where in the case of variance, it is xi minus mu whole square. But here we are not taking the whole square, but we are taking the modulus value. And for group data, it is the similar kind of 1 by summation fi, that means capital N, summation I equal to 1 to fi into mod of mi minus mu. What is this mi? Mi is the midpoint. So it is the similar kind of variance formula, but instead of square, we are taking the modulus value. Now, this is also sometimes this significance. It is absolute value of the deviations, and it is less sensitive of the extreme outliers, right? If you have a outliers value and then that this square term, that suppose a very big data you have, that minus this mu, actually it will make you, if you take the square of it, it will affect more, right? So it is, if you just, but just if you take the this modulus value instead of taking the square, it will be less effective if you have a outlier. So sometime to avoid the outlier, instead of variance, we used to take the mean absolute deviation, correct? Now if you do one example, you can easily get the value. So how to get the that MAT value for this ungrouped data, the same example. So for the ungrouped data, the MAT formula was summation of mod of xi minus mu. Now mu is, for this case, mu is equal to 10. So 10 minus 10, 0, 0, 0, all these cases 0. So the for the MAT of this test 1, it is 0. For the second case, it is mod of 10 minus 8. So in this case, it is 2. Right? In this case, it is 1. In this case, 1. In this case, 0, 0, 0. All this 0, then 1, 1, and 2. So if you add all of them, divided by 10, if you do, this value is 0.08. And the third case, so this is 10 minus 5 modulus value, it is 5, 5, 0, 0, 0, 0, 0, all this value, and then 5 and 5. So again, if you just do add divided by 10, so it is 20 by 10, it is equal to actually 2. So MAT value is also somehow we have understood, it gives the measures of dispersion. So how the data are varying with each other, varies with each other, MAT value is to get that value. Right? Now if you have a group data, what you will do? So the same way, make a table, right? Make the frequency table, and then the midpoint, calculate mod of x minus mu value. So anyway, for this same example, we already calculate the mean. Mean was 27. Then after that, you need to calculate that mod of x minus mu and f into this. So if you calculate the variance, you could have done that m minus mu whole square and f into m minus mu whole square. But it is mean absolute deviation we are calculating, MAT value you are calculating. Therefore, we want to get this value. So make the table and then get it and put it in the form. You will be getting this MAT value is 9.44. So I do not have to solve this example, just you look at the formula. These are very easy, but only point is you have to do them very, very carefully, slowly and carefully. Right. Now, I want to discuss another thing which is known as coefficient of variance. It is again it identifies that how the measures, how the data are varied with each other. Now, what is the coefficient of variance? The coefficient of variance CB is a standardized measures of the dispersion of a data set expressed as a percentage. Right? So it is the ratio between sigma by mu. It is sigma by mu times 100. It is sigma divided by mu into 100. That is called the coefficient of variance. What is sigma? It is the standard deviation. What is mu? It is the mean of the data set. Now it has actually some significance. Why you otherwise why you need to get another thing? See, it is the ratio between two parameters, right? That sigma and mu. It is of sigma and mu are of the same unit. So if you make its ratio, that CB is actually unitless, right? So the significance, the first significance is CB provides a unitless measures of variability, right? So allowing compressing access across the database with different units of scales. So it will be easy to compare some different database which are having different kind of units. But at least CB you can say that okay, what is the coefficient of variance? You can identify there, right? So it is somehow significant in that way. And then it is useful in determining the relating to risk consistency, right? So like the variance, it also determine what is the risk. So if the CP value is more, that means risk is more. If the CP value is less, that means it is more consistent, more stable. So it uses in finance, manufacturing, scientific research. In many places it is used, and it is ideal for comparing dataset with different means. And higher CB indicates it is more variations are there, lower CB indicates the data are more stable. Now one more thing, if your mu value, that the mean value, if it is very close to zero, that CB value actually gives you a very big number, right? Sometimes that will mislead to identify the data, right? So you have to take care of that situation. Now then, for this example, we have already calculated the standard deviation, the sigma value. We have already calculated the mu value. Then what is the CB? It is sigma divided by mu into 100. So whether it is the group data or ungrouped data, the formula is same. Sigma divided by mu into 100. So sigma is 1 point for the first data, it is 0. So the sigma divided by mu into 100 will give you 0. For this one, it is 1.09545 divided by mu is 10 into 100. If you calculate, the value is 10.95%. In the third case, it is this one. So see, if for the case of a CB also, this third test having more CB, so the data are more variations is there. So this is somehow again measures the measures of dispersion, how the data are varied with each other. So it has little less, so this percentage is this, right? In this way it is significant. So the note you have to take that for group data and ungrouped data, the formula is same. Now one example is given where that some n value is given and the mu value is given, that means mean is given, and summation xi square is given. You have to find the coefficient of variance. Now to get the coefficient of variance, you need actually sigma divided by mu into 100. So you need the sigma. So what is, how to calculate sigma? First calculate sigma square. Now what is sigma square? Variance formula for some coefficient of variance. So you consider them as a group data only, right? It's because summation xi square is given. Now it is summation of xi minus mu whole square divided by n. Now this formula you can actually write it in this way also. We know this summation of xi square divided by n minus mu square. This formula we know. Now what other things are given? Summation of xi square, it is 1530 divided by n is what? N is 10 is given. What is mu? It is 12. This square. So if you simplify it, you'll get this value is actually 9. Then what is the sigma value? Sigma is 3. And then what is CV value? CV is equal to sigma divided by mu. Mu is equal to 12 into 100. So 3 fours are this, 425. So this is 25%. So the CV coefficient of variance is actually 25%. Yes, this one we have already done. Now look at this example. Look at the second example. The coefficient of variance of two datasets 60% and 80% respectively. The first dataset has highest standard deviation, which is 12. The second dataset's standard deviation is 50% more than the first database mean. Find the means for both the database. Now, this is actually very easy problem. It is just you have to this class 10 level problem if you know the formula. Right. For the first data set, what are the things are given? The CV1 is given. Right. For the first data set, that means coefficient of variance for the first data CV1, I'm saying it is given as 60%. And standard deviation is given as 12. So maybe I'm saying it is sigma 1 is 12. Can't you find the mu from there? Because you know the formula, right? So I can calculate the mu because we have CV is equal to sigma 1 by mu 1 into 100. So I can get get the solution for mu 1 from there. So I got the mu 1 value. Then the next data set, what are the things? We know the CVs. And the second case, the standard deviation is 50% more than the first data set mean. So what is the standard deviation? First data set mean is 20. Right, first data set mean is given as 20. So the according to the question, the second data set standard deviation is 50% more than. So it is mu1 plus 50% of mu1. If you calculate it, it is actually giving you 30. Then again, put it in the formula of CV. You solve for mu2, you will get the value is 37.5. This is very easy problem, so I'm just showing you the solution. But instead of that, I want to discuss this problem. Now, the arithmetic mean of runs scored by three batsmen Vijay, Subhas, and Kumar of the series of 10 innings are 50, 48, and 12. That means their average is this run, and their standard deviations are 12, 15, 12, and 2, respectively. Then you have to calculate who is the most consistent of these three. And if one of these, the three is to be selected, whom you will select. So what it is given, the mu, sigma, and are given for both the cases. So what you will do, you find the coefficient of variance, right? So for each of the player, we will calculate the CV. So sigma divided by mu into 100. Now sigma is given for each of the player, mu is also given. Calculate the value. So if you calculate, it is for Vijay, CV of Vijay is actually 30%. If you get then CB of Subhas, if you put the value, you will get 25%. And CB of Kumar, you got the CB is equal to 16.67%. Right? So who is the most consistent then? Whose CB is less? Right? Coefficient of variance. So therefore, this Kumar is actually more consistent. But this run is also less, na, in case of a Kumar. So Kumar is somehow very consistent, but he or Kumar used to score very like around 12 around runs for each of the matches. Whereas who is the who scores more? Although the Vijay, his actually average score is 50. So in 10 match, if he has done 10 into 5, so 500 runs. So in some matches he must have got a very less mark, less run because its CV is more. But average calculation, if I just check that who is the good performer in terms of run, we have to think for Vijay. But in case of consistency, we will think for Kumar, right? So the conclusion is the most consistent player is Kumar because it has lowest CV, and best overall performer is Vijay because it has the highest mean, because he scores very well. In some matches, he may be getting very less runs, but overall run is the total run is 500. So he is scoring more. I hope it is clear. Then we have that similar kind of example. Just read it and try to solve it. This is for again for your practice purpose. We kept it. Just look at the problem and take it as a homework. Similarly, look at this problem. Think of it. So here you have to solve the this. Sometimes you have to solve the CV. Sometimes you have to solve the mean. Sometimes you have to solve the variance. For different kind of data sets are given, which is very easy. I am not going to discuss. So the some of the things, some of the content we have taken from mostly this book, right? I hope you understood. These are again, I am telling you repeatedly, these statistics problems are actually very easy. Your first job is you have to remember the formula. Of course, you have to understand that how these formulas are signifies, but mostly you have to remember all of them. Next job is you have to carefully apply this formula very slowly, very carefully. If you do mistake in some one place, it will affect the whole table. Correct? So please do care of it. Thank you very much. We'll meet in the next video.